సో ఈ కండిషన్ ఏమని చెప్తామంటే గివెన్ మ్యాట్రిక్స్ ఈజ్ రో ఈక్వాలెంట్ టు 2/2 ఐడెంటిటీ మ్యాట్రిక్స్ అని చెప్పేస్తాం. సో ఆ RHSI లో ఉన్న హాఫ్ మ్యాట్రిక్స్ ఏమని చెప్పేస్తామంటే అవర్ రిక్వైర్డ్ మ్యాట్రిక్స్ అని చెప్పేస్తాం. ఈ ఫార్మాట్ లో కూడా మనం ఫైండ్ అవుట్ చేయొచ్చు. హియర్ వీ డిడ్ నాట్ అప్లై ద జనరల్ ప్రొసీజర్ ఆఫ్ ద కోఆర్డినేట్ వెక్టార్. ఓకే, మనకు ఫార్ములా ఉంది కదా. వాట్ ఈస్ దట్ ఫార్ములా? ఈ ఫార్ములాని మనం ఏం యూజ్ చేయలేదు. Just by the definition only we applied the procedure. So in this format we can find the solution for the first question. Okay, so this is the our required solution for the problem. The change of coordinate matrix from B to C is given by in this format only 2 minus 3/2 minus 3 5/2. That is the in first question first subcondition. Next second subcondition, the change of coordinate matrix from C to B. That is, okay, mathematically we can write change of coordinate matrix, that is P from C to B equal to formula is the change of coordinate matrix from B to C ki inverse apply chestam. Neeku C to B kavalante B to C ki you have to apply the inverse. Already you know very well B to C. Okay, substitute that matrix 2/2 matrix from the previous slide. Okay, so therefore apply that inverse. Here it is a 2/2 matrix na, so 1 by det A. Okay, so 1 by det A into adjoint A. Adjoint A. Here not 1 by det A. So 1 by det of formula 1 by det of P from B to C. Okay, adjoint of P from B to C. So this is the formula to find the that inverse. So apply the condition, determinant condition AD minus BC, and apply the adjoint matrix formula. You know very well, D minus B minus C. Okay, D minus B minus C A, whenever capital A is equal to A B C D. So if you simplify the values, then you will get 1 by 5 minus 9/2, resultantly 5/2 3/2 3/2. So therefore the change of coordinate matrix from C to B equal to 2 into this value. So if you multiply with 2, you will get in this format. The change of coordinate matrix from C to B equal to multiply with 2 that matrix, then you will get, so 2 will get cancelled 5, 2 will get cancelled 3, 2 3 is 6, 2 2 is 4, 5 3 6 4 is the our required the change of coordinate matrix from C to B. Okay, so these are the quite. సో ఇక్కడ మీకు ఒక చిన్న డౌట్ ఏంటంటే ఇది వచ్చింది కరెక్టా కాదని మీకు డౌట్ ఉంటుంది కదా. సో ఇప్పుడు మీరు ఏంటంటే ఫర్ ఎగ్జాంపుల్ టు క్లారిఫై యువర్ డౌట్ ఐ విల్ డూ వన్ ప్రొసీజర్. సో దట్ ఈస్ హియర్ వీ హ్యావ్ 2 minus 3/2 minus 3 5/2. Okay, so this matrix is the from B to C. B to C. Next 5 3 6 4. 5 3 6 4 is the P from C to B. ఈ రెండింటిని మల్టిప్లై చేసుకోండి. మల్టిప్లై చేసుకుంటే ఏమొస్తుందంటే మీకు 2/2 కాబట్టి, సో 2 5s are 10 and minus 3/2 into 6, 2 1 minus 9. Okay, so next 2 3s are 6 minus 2 2s are cancel, 2 2 minus 6. Okay, minus 3 minus 15 plus 5/2 into 6 plus 15 minus 3 plus minus 9 5/2 into 4, 2 1s 2 2s are 4 4 2 2s are 4, 2 5s are 10. Okay, plus 10. Okay, so in this format, then you will get 10 minus 9 1, 6 minus 6 0, plus 15 minus 15 0, minus 9 plus 10 1. What is this? Identity matrix only. That means whenever you get that change of coordinate matrix values, okay, so in the examination if you have some time, so you can cross check in this format. Those two matrices are inversible matrices. Inversible. Okay, inversible matrices. That means P from B to C into P from C to B equal to capital I. Equal to capital I. Then only we can apply this formula. Okay, from that equation only we can derive this formula. Okay, so now you understood. So okay, whenever you get the B coordinate vectors of in this format, so you can multiply both them. So then you will get one identity matrix. Then those two matrices are inversible matrices. Okay. So in this format also you can cross check the given solution. That is the explanation. Next, you can see that the second problem. In that second problem, given basis is capital B equal to 1 minus 2t plus t square, 3 minus 5t plus 4t square, comma 2t plus 3t square. 2t plus 3t square. So next here, given capital B is a basis B1, B2, B3. Here B1, B2 is the column matrix. The column matrix ni how we can obtain? From this quadratic equations only. From this quadratic equation, scalar values only we can obtain the B1, B2, B3 values. And standard basic capital C is equal to 1t t square. You know very well. Here the vector space capital V is equal to P2. In P2, standard basis is in this format only 1t t square. And whenever you apply a quadratic equation, so these values must and should. One is nothing but constant. T is the first variable. T square is the second variable. Okay. So therefore, the coordinate vectors of B1, B2 and B3 are, okay, this coordinate vector of B1, B2 are respected to given basis capital B is, so first vector B1 with respect to C is you will get, so here you can observe the constant values are coefficient values of small 1 and small t and small t square. Here you can observe that from this condition 1 minus 2, 1 minus 2t plus t square is there. Here first constant is 1, t coefficient is minus 2, t square coefficient is plus 1. Those scalar values only here taking as a coordinate vector. Coordinate vector is only scalars only. It is actually it is a linear combination amount. Here we have b1. Okay, so here we b1 with respect to c equal to 1 minus 2t plus t square is a linear combination. Where so therefore 1 into actually it is a c1 minus 2 into c2 plus 1 into c3. 1 into c3. Where c1, c2, c3 are the vectors. These are the standard base. Here you can see capital C is equal to 1t t square is there na. Okay. C1, C2 are the standard basis. A standard basis ni మనం ఈ format లో represent చేసుకోవచ్చు. Similar గా from that quadratic equation, so B2 over C equal to we can write the coordinate vector. Coordinate vector equal to scalar values 3 minus 5 plus 4. 3 minus 5 plus 4. From this third quadratic equation, the coefficients are 0. Why? Because there is no constant. Small t coefficient 2 and t square coefficient is 3. In that format, we can obtain the 3 vectors in the basis capital B related to the basis standard basis capital C. After getting those values, the change of coordinate matrix from B to C, the change of coordinate matrix from B to C is given by, this is the formula. Okay, that is capital B from B to C equal to, so B1 with respect to C, B2 with respect to C, B3 with respect to C. So therefore, P from B to C is given by, substitute the corresponding values from the obtained given data. So therefore, 1 minus 2, 0 is the first column, 3 minus 5, 4, the second column, 0, 2, 3 is the third column, that is the 3 by 3 matrix. Always you will get square matrix only. This change of matrix from B to C or C to B is always a 3 by 3 or 2 by 2 or n by n square matrix only. Later, x is equal to minus 1 plus 2t. Already minus 1 plus 2t is the already there in the given problem. Okay, minus 1 2t is the minus 1 plus 2t is the given vector in the problem. That vector I am taking it as small x. Okay, so that is only here small x is equal to minus 1 plus 2t. For that x also, with respect to capital B, we can find a coordinate vector. Then the coordinate vector, you can write x with respect to capital B satisfies the given condition. Okay, whenever you get a vector, we can write the coordinate vector. So therefore, according to the formula, okay, so therefore from the formula, we can write this value. So P from B to C into x over capital B equal to x over capital C. So therefore, you know very well that value is equal to minus 1 to 0. Here, constant value is minus 1. Small t coefficient is 2. and there is no t square term. So therefore 0 into t square kabatti that value equal to we can write 0. So therefore that value we can write. So now the augmented matrix is given by augmented matrix for these two values. LHS value and RHS value we can write. Okay. So for that value 1 minus 2 0, 3 minus 5 4, 0 2 3. So this one is the change of coordinate matrix from B to C, and this one is the coordinate matrix of X with respect to capital B. For those two, it is a one rectangular matrix, 3 rows and 4 columns are there. To obtain the required condition, so converting this matrix into reduced echelon form by applying that elementary row operations. Okay, so by applying that elementary row operations, so here this one is the pivot position. So minus 2 and third row 0 is already there. In the second row minus 2 we have to make this value equal to 0. To do that process we are selecting row 2 as row 2 plus 2r1. Okay. Next row 3 is also there, r3 minus r1. So to do that process you will get that resultant matrix in this format. Row 1 1 3 0 minus 1, and row 2 after applying that row operation the resultant row 2 is 0 1 2 0, and the row 3 0 1 3 1 is the value. Next to here this is the pivot column. First column is the pivot column. So for the pivot column we done with that property. Next this one is the pivot position. In second column, second row, 1 is the pivot position. Now this value we have to make equal to 0, and this 3 we have to make equal to 0. To do that process, so now I am implying row 3. R3 implies R3 minus R2. Then you will get in this format. So 1 0 0, 3 1 0. So 0 2 1 minus 1 0 1. So in this format you will get the required obtained matrix in this format. So here this value is 0. Below the pivot element value is 0. Next above the pivot element 3 is there in row 1. So to do that 3 is also equal to 0. You can do simultaneously, not step by step. So this row 1 operation you can also do in the previous step also. Here also you can write. Okay, along with this condition here also you can write row 1 implies row r1 minus 3r2. R1 minus 3r2 you can do in this format also. Why? Because here we did two row operations simultaneously. Okay, so it is better to do one by one instead of doing 2-3 properties at once. Okay, it is better to do one by one because you will get clarity. Okay, without confusion you will get clarity. So therefore for the examination also it looks very good. So therefore if you do the step by step for each and every step, if you apply the one row operation, then you will get clarity. The number of steps will increase, but it will looks very nice. So therefore after doing that process, here 3 will be there, but the 3 is also 0. So therefore pivot, first pivot column, second pivot column. Next pivot choice is this one, third row, third column. 1 is there, already 1 is there. So here this 2 we have to make equal to 0. This minus 6 we have to make equal to 0. Those are the above entries of the pivot position. So to do that process, those two elements are existing in row 1 and row 2. That's why I am applying the processes. R1 implies R1 plus 6R2, R2 implies R2 minus 2R3. ఏం లేదు, ఇక్కడ మీకు 2 ఉంది కదా, ఈ 2 తోటి ఈ వాల్యూని మల్టిప్లై చేయాలంటే R1 కి 2 మల్టిప్లై చేయాలి. 2 minus 2 0 అయిపోతుంది. నెక్స్ట్ ఇక్కడ మైనస్ 6 ఉంది కదా, ఆ మైనస్ 6 కి ఇక్కడ ప్లస్ 6 అప్లై చేయాలి. మీరు ప్లస్ 6 తోటి మల్టిప్లై చేశారనుకోండి, ప్లస్ 6 మైనస్ 6 0 అయిపోద్ది. సో అంతే. సో ఈ ఫార్మాట్ లో మీకు ఈజీగా ఉంటుంది. సో ఆఫ్టర్ అప్లైయింగ్ దోస్ ఎలిమెంటరీ ఆపరేషన్స్ దెన్ యూ విల్ గెట్ that entire matrix into row reduced echelon form. Here you can observe that this one is the pivot position, this one is the first pivot column, and this one is the pivot position, that one is the second pivot column, this one is the third pivot position, that one is the third pivot column. So there is no possibility for the next pivot. Why? Because we have only 3 rows only. In each and every row there exists one pivot position. There are 3 rows and 3 columns, pivot columns. So now after getting that value, here you can observe that this resultant matrix is the 3 by 3 identity matrix. 3 by 3 identity matrix. This remaining one column matrix gives the capital B coordinate vector of small x. Capital B coordinate vector of small x. Okay, since what we have the B coordinate vector for x is equal to minus 1 plus 2t is, so 5 minus 2 plus 1. 5 minus 2 plus 1. That is the b coordinate vector of small x. minus 1 plus 2 కి plus 2 కి b coordinate vector ఏంటంటే మనం ఏమని చెప్తామంటే 5 minus 2 plus 1. 5 minus 2 plus 1. So in this format we can obtain the b coordinate vector of small x. So just by applying that the row reduced echelon form only we are obtaining the problem sum. So with this explanation you have to think that how the significance of row reduced echelon form and echelon forms and row operations in this linear algebra. In this perception only, at the beginning of this subject only, I clearly explained the row reduction and echelon forms from the definition and how we can apply the procedure. So you can watch those videos once again. Okay. So if you have any doubts, you can also mention in the comment section, in the discussion section, in the SIA prep app. Okay. So there are a lot of problems based on this method in the SIA publications linear algebra material. Go through all those problems once again. So if you have any doubt, you can also comment in the SIA prep also. So therefore, we will be always available for your valuable comments and we will be always waiting for your suggestions. Okay. I hope you understood this lecture very well. This is the total explanation of this lecture. So in the next lecture, we are coming with another topic. Make a perfect practice. Prepare well. Until bye. Thank you.